Hi everyone, and welcome to a short video on my Sensing and Internet of Things project, LibAirty. The project aims to give users more control to improve the quality of their air indoors using predictive modeling techniques to forecast what the pollution levels would be in an hour, based on external weather conditions. Accordingly, the user would be instructed to open their windows to recirculate fresh air, or close windows if we predict the air is just going to get nastier in the next hour, so we don't want it entering our room. So with that, let's dive a bit more into the project. So the first step was to gather current weather data through physical sensors and from openweathermap.org, and to also gather data on the indoor air quality. The physical setup involved an Arduino connected to an outdoor and an indoor humidity and temperature sensor and an indoor air pollution sensor, all connected together using breadboards and wiring, as you can see here. The system was then placed in a high cupboard in my room, out of the way of any physical interactions or interferences or any localized bodies of heat. As you can see here, the indoor temperature sensor and indoor air pollution sensor, as well as the Arduino board, were fixed securely in place. A long cable runs from the Arduino board out to the balcony, connecting to the outdoor temperature and humidity sensors, which are placed on a breadboard and then securely held in place in case of any windy conditions. To tie the whole system together, there was of course an Arduino program that essentially took the data from the sensors and data from openweathermap.org and sent it through to an online storage service called ThingSpeak. After a lot of coding and some thorough testing, the program was finally ready to go, and I set it up for a full week to gather air pollution and weather data. There was a time when the Wi-Fi got disconnected and the power cut out. This meant that the sensors were not gathering data and this data was not being stored on ThingSpeak. To cater for this, I had luckily written in some code earlier on that sent me an email notification in case there was no data that had been uploaded to the ThingSpeak channel in the last 15 minutes. This meant I could then go to my physical system and check it out and see what the problem was. The next step was to identify correlations between the outdoor weather and the indoor air pollution, and to figure out if there was a way we could come up with a predictive model that could then use outdoor weather data to predict what the indoor air pollution would be. I ended up creating two different predictive models, one based on the physical sensors that used to be collecting weather, and the second based on the openweathermap.org data that I had been collecting as well. I then uploaded these models to MATLAB, where essentially the code would run every hour. It would predict what the future weather would be in an hour's time. It would send the respective weather, whether it was based on historical sensor data or whether it was gathered directly from openweathermap.org, and it would push the data through each of the respective predictive models, and it would come up with a predicted air pollution output value. This value was then stored in the predicted output air pollution channel on ThingSpeak, which was then later used to actually instruct the user on whether to open or close their windows based on what the air pollution would be in an hour. So the last bit relied on me communicating this information with my user, which would rely on creating a custom-made website to push the information to, where the user could then read those instructions and act accordingly to open and close their windows. The first step was to code the website using HTML, CSS, and Java, and then explaining the concept to the users, letting them test it out, and accordingly changing the design and the interface so that it was clear, easy to use, and got the job done. So let's have a look at the website itself. How do we get there? We go to liberty.herokuapp.com, press enter, and then we come to the main home page, which gives us a bit of an introduction on what the project is about, and then takes us to the main early prediction, early response section, which tells us what the air pollution is predicted to be in an hour, which is 432 parts per million, which is also represented in a gauge form. As you can see, it's in the orange zone, which is relatively safe. So it tells us to open our windows so that we can get the fresh air in and get the air recirculating. We can also look at what the air pollution looks like at the moment, which is 446 parts per million right now, again in the orange safe zone, and it gives us the air is not amazing, but it's definitely not bad, personalized quote. There's also the option to trigger this toggle, which then flicks between the sensor-based predictive model or the Open Weather Map API-based predictive model, as we mentioned earlier in the video, and it live changes the gauges and the values, as you can see here. So let's go to the About page. That essentially covers what the project is about, the video you're watching right now, and also contains the GitHub repo that contains all the code for the website and for the sensors itself. There's a project flow that explains the entire process that we've just gone through in the video in a more graphical format, and a final bit about me as the designer. The last page is the View Live Data page, which is the data gathered in ThingSpeak and essentially broken down into the 4 channels: raw data, smooth data, predicted input data on an hourly basis, and predicted output data on an hourly basis as well. Each channel had a series of graphs that it was collecting, and these graphs have been directly embedded in from ThingSpeak and are also interactive so that you can look at each point, the time it was taken, and the value of the point. And that's LibAirty. Thanks for watching.